Today, we'll be solving LeetCode 417, Pacific Atlantic Water Flow. In this problem, we are given a grid of numbers where each cell represents the height of the land at that point. The Pacific Ocean touches the top edge and the left edge of the grid, and the Atlantic Ocean touches the bottom edge and the right edge of the grid. Rainwater can flow from a cell to another cell if the neighboring cell has a height less than or equal to the current cell. Our task is to find all the cells in the grid where water can flow to both the Pacific Ocean and the Atlantic Ocean. At first glance, this problem looks complicated, but let's carefully break it down. The key idea is that instead of simulating water flowing from every single cell toward the oceans, we can reverse our thinking. We can start from the oceans and move inward. For the Pacific Ocean, we begin from the top row and the left column, and we run a search to find all the cells that can flow into the Pacific. For the Atlantic Ocean, we begin from the bottom row and the right column, and we run a search to find all the cells that can flow into the Atlantic. In the end, the answer is the intersection of these two sets, the cells that can reach both oceans. We can solve this using depth-first search, also called DFS. Now let's walk through the code in detail. We start by defining a function called Pacific Atlantic that takes in the matrix heights. The first thing we do is check if heights is empty. We say if not heights or not heights at 0, then return an empty list. This handles the edge case where the grid is invalid. Next, we get the number of rows by saying rows equals length of heights, and the number of columns by saying cols equals length of heights at 0. These will help us navigate through the grid. We then create two sets called Pacific and Atlantic. Each of these sets will hold the coordinates of cells that can flow to their respective ocean. Now we define our DFS function. We say def DFS with arguments r, c, and visited. The first thing inside DFS is to add the current cell to the visited set, because we are now marking this cell as able to reach the ocean we are exploring. Then, we loop through the four possible directions, up, down, left, and right. For each new row and new column, we check two conditions. First, we make sure the new cell is inside the grid. Second, we check if the new cell's height is greater than or equal to the current cell's height. This is important, because water can only flow downhill or on flat ground, which means if we are traveling backward from the ocean, we can only move to a neighbor with equal or greater height. If these conditions are met and the neighbor has not been visited yet, we call DFS on that neighbor. Next, we run DFS for all the Pacific Ocean starting points. That means every cell in the top row and every cell in the left column. We pass in the Pacific set so we know which cells can reach the Pacific. Similarly, we run DFS for the Atlantic Ocean starting points, which are every cell in the bottom row and every cell in the right column. We pass in the Atlantic set for those searches. After both searches are complete, the Pacific set contains all cells that can flow into the Pacific Ocean, and the Atlantic set contains all cells that can flow into the Atlantic Ocean. The final result is simply the intersection of these two sets. So, we say result equals the list of cells in Pacific intersect Atlantic, and we return result. In terms of time complexity, this solution runs in O of m times n, where m is the number of rows and n is the number of columns. This is because each cell is visited at most twice, once for the Pacific search and once for the Atlantic search. The space complexity is also O of m times n due to the recursion stack and the visited sets. And that's how you solve LeetCode 417, Pacific Atlantic Water Flow. Thank you for watching and let's keep learning.